Welcome to the Deep Dive, where we unpack the most interesting and impactful research. Today, we're zeroing in on a brand new academic paper. It's presenting what looks like a potentially game-changing approach to how AI systems tackle really complex questions.
Yeah, the kind that need more than just recalling facts, right? Where you have to weave things together.
Exactly. This paper introduces a novel system using a team of AI agents. They iteratively search, learn, and refine their understanding. And apparently they're getting significantly better results than standard methods on these tough, multi-step reasoning tasks.
Right. Think of it like moving beyond just one search, which might be flawed, to something more nuanced, self-correcting almost, like a research team tackling a hard problem together. The core idea is having these multiple LLM agents, language model agents, building and maintaining their own internal knowledge base. It evolves as they go.
Okay.
And that knowledge then helps them ask better questions, filter out irrelevant stuff, leading to much more accurate answers for those complex multi-part questions.
Okay, so this paper, it lays out a specific structure. They call it SDDSD. A few key stages.
Yeah, that's the framework.
First, they summarize their system, knowledge-aware iterative retrieval for multi-agent systems. So basically, they've designed it so gathering info from the outside world is separate from this internal knowledge cache, which is always updating.
Exactly.
And this internal knowledge makes the agents better searchers and better evaluators of information.
And that separation is really clever, I think. Instead of just, one-shot search and answer, or even simple back and forth, this creates a proper learning loop.
Right.
The agents are actively building their understanding as they explore. And that understanding directly shapes what they do next. They even try different interaction styles. Sometimes the agents compete. Sometimes they collaborate more directly.
And the results suggest this really pays off.
Seems so. They saw consistent improvements over the more basic methods. And the advantage was even clearer on those really intricate multi-hop questions.
The ones where you need to piece together info from different places.
Precisely. The kind where you need info from source A to understand source B to get to the answer.
It sounds like the harder the question, the more this multi-agent approach helped.
Which makes sense, right? It kind of mirrors how we tackle hard problems. Yeah. Simple question. Quick search might be fine, but connecting different ideas, drawing inferences, having multiple perspectives, different agents exploring different angles and comparing notes, that can be really powerful.
Okay, let's dig a bit deeper into the mechanics. You mentioned stages. Query planning, knowledge extraction, contextual filtering. How do those actually work?
Right, so query planning. The agents use what they've already learned, that accumulated knowledge, to figure out what to search for next, or maybe refine an earlier query. They're trying to anticipate what they still need and avoid searching for the same thing twice.
Makes sense.
Then knowledge extraction. They pull relevant bits from the documents they find and distill them into verified facts. And crucially, they also identify gaps, what they don't know yet. That's how the internal knowledge base grows.
Okay, so it's building up this validated internal picture.
Exactly. And finally, contextual filtering. They use that accumulated knowledge again, this time, to weed out information that seems irrelevant or maybe contradicts what they already know. It helps them focus on the most important pieces.
So it's like a research team getting smarter as they go. They learn what's useful, what's not, and refine their focus. And this whole cycle repeats until they've filled the gaps.
That's the idea. Iterate until the information needs are met.
And you mentioned the multi-agent aspect helps speed things up.
Yeah, they can run some of these processes in parallel. Multiple agents searching or extracting knowledge simultaneously.
So what's the big breakthrough here? What makes it novel?
Well, the researchers really emphasize how they balance exploring broadly for information with staying accurate. That's a tricky trade-off. Standard AI models often struggle to refine search results over multiple steps. Judging relevance midstream is hard. This system tackles that directly by giving the agents some autonomy. They make decisions based on their internal knowledge. This targeted way they spot gaps in requery helps overcome some LLM biases, allows for self-correction.
And it sounds more trackable too.
Yeah, the structured way they maintain queries and knowledge makes it easier to see the reasoning path and spot potential errors, which is a big plus.
Okay, so how did they actually test this? Sounds like a pretty thorough evaluation.
They did. They used a mix of QA datasets, multi-hop ones like Hotbot QA, 2Wiki multi-hop QA, Music. These really test that multi-step reasoning.
The hard stuff.
Exactly. But they also included single-hop datasets like Natural Questions, Squad, Trivia QA, just to see how it handled more direct questions. And for the basic retrieval part, they use BM25, which is a pretty standard technique.
And they compared it against other methods, not just in isolation.
Right. They needed baselines. So they compared against a simple single-step retrieval. They called it naive RAG. Then their own system, but with just one agent. And finally, the full multi-agent system, usually in a competitive setup with up to 3 agents.
Okay. And what about the models powering the agents?
Interestingly, they mostly use GPT-4amini for the agents, a smaller, more efficient model, though they did try the bigger GPT-4o for some of the really tough tasks.
And for actually generating the final answer?
Mainly GPT-3.5 Turbo 0125, but they tested GPT-4amini there too.
And the metrics were retrieval F1 and answer F1. Basically, how well did it find the info and how good was the final answer?
Exactly. Measures of relevance and accuracy.
So what were the big takeaways from the results? What jumped out?
Well, the agent-based systems, both single and multi-agent, consistently beat the basic single-step retrieval. That was pretty clear. And the improvements were most dramatic on those complex multi-hop tasks.
As you'd expect, maybe.
Yeah, and the multi-agent systems generally showed an even bigger advantage there. Sometimes their system even found better supporting evidence than the original ground truth data had, probably because of that structured, iterative approach.
Wow, okay.
They did find diminishing returns after about 2 agents, though. Adding a third didn't always give a huge extra boost.
So maybe a sweet spot around 2 agents.
Seems like it. And maybe the most surprising thing, that smaller model, GPT-4amini, often performed just as well as the big GPT-4o in the multi-agent setup.
Really?
Yeah, it really highlights how much the architecture itself is doing the heavy lifting in terms of reasoning.
That's a fascinating point. The structure matters as much, or maybe more, than just the model size.
Absolutely. Their analysis suggested that 2 agents often hit that best balance of performance versus cost. They also compared their query refinement approach to other iterative methods, like chain-of-thought retrieval, and found theirs had advantages in some complex cases.
And it was faster sometimes, too.
Their efficiency analysis suggested the multi-agent systems could converge on an answer more quickly, especially for the harder questions. They even walked through a detailed example, a 4-hop question, showing how the agents built knowledge step by step, how they seemed to specialize a bit, adapted their searches, and finally got the right answer. It's quite convincing.
Okay, to really appreciate this, maybe we should step back, put it in context. What led up to this kind of research?
Good idea. This whole area builds on retrieval augmented generation, or AG. We've talked about RAG before, the idea of giving language models access to external knowledge to make them more factual.
Right, grounding them in real information.
Exactly.
Yeah.
But a big challenge with standard AG is, well, garbage in, garbage out sometimes. If that first retrieval step pulls in irrelevant or misleading stuff.
It can mess up the whole process.
Yeah.
Especially for multi-step reasoning.
Precisely. And the language models themselves, these large LLMs, they weren't explicitly built for complex multi-stage reasoning. A lot of it is implicit, hard to track, prone to errors compounding.
Yeah, I can see that.
So people have tried iterative retrieval before. Search, look at results, search again based on that.
But that had issues.
Often, yeah.
Yeah.
High computational costs, sometimes running into limits on how much text you can feed back into the model, the context window problem.
Ah, right.
So this paper feels like a real step forward, introducing this explicit knowledge awareness, this internal cache, and leveraging multiple agents working together or competing.
Mm-hmm.
It's just a more sophisticated way to handle iteration.
Okay, so boiling it down, key innovations are?
First, that dynamic internal knowledge cache. It actively guides the search and the filtering. That's central.
Right.
Second, separating that internal knowledge from the raw external sources.
Mm-hmm.
Helps avoid reinforcing biases, potentially. Third, the multi-agent approach allows for parallel exploration, covering more ground.
Putting diverse perspectives on the problem.
Exactly. And fourth, it really optimizes that trade-off between exploring widely and staying accurate.
And fifth, maybe the practical point that smaller LLMs can be really effective in this setup.
Yeah, that's huge. Makes advanced reasoning potentially much more accessible.
Which leads right into real-world implications. Where could we see this making a difference?
Oh, quite a few areas, I think. You could imagine much more robust AI for complex information seeking. Think scientific research, synthesizing findings from loads of papers.
Or financial analysis, connecting economic dots.
Definitely. Or even sophisticated customer support, handling really complex multi-part problems. And the efficiency point is key. Using smaller, cheaper models effectively could democratize this kind of advanced AI reasoning.
Makes it more practical for more people and organizations.
Right. Plus the traceability aspect we mentioned. That structured process could lead to more transparent, auditable AI. That's critical in fields like medicine or law.
Where you need to know why the AI reached a conclusion.
Exactly. And really, any situation needing synthesis from lots of potentially messy or conflicting sources could benefit. This system seems designed to find coherence.
Okay, this is always the fun part for me, thinking ahead. Based on this paper, what new research directions pop into your mind? Let's do our novel notions.
All right, novel notions time. Okay, first idea. It builds on the agent interaction. The paper looked at competitive agents. What if we made their roles more dynamic, adaptive?
So not just fixed as competitive or collaborative, but changing based on the situation.
Precisely. Imagine a system where agents start maybe competing to explore broadly. But then, as the system figures out who has relevant knowledge for a specific remaining gap, those agents could maybe form a temporary, focused, collaborative team.
Like self-organizing specialists.
Kinda. It can mimic how human expert teams work.
Yeah.
Right. The person with the right skills steps up for a specific subproblem. It might be faster, more efficient, especially for really gnarly, complex problems.
The paper even hinted at some implicit role differentiation already happening.
Exactly. So this would just make it more explicit and dynamic. The potential, more flexible, adaptable AI teams. Probability. I'd say high probability of efficiency gains on complex tasks. Medium probability, it leads to fundamentally new problem-solving strategies.
Interesting. An adaptable AI research team. What's notion number 2?
Second idea focuses on that internal knowledge cache. And the paper talks about distilled facts. What if we made it more structured? Like using a knowledge graph.
So instead of just a list of facts, it's a network. Concepts, relationships, all linked up.
Exactly. You'd combine their iterative agent framework with techniques that automatically build and update a knowledge graph from the stuff they retrieve.
Obvious benefit might be better querying of the internal knowledge, more efficient planning.
Yeah, that's the obvious part. A structured graph is easier to query efficiently, could improve planning and filtering. But the non-obvious, maybe more exciting part, explainability.
How so?
If you track how that knowledge graph evolves over the iterations, watching it grow, refine, see connections form, that could give you a really clear picture of the system's reasoning process.
Visualizing the thinking.
Kind of.
Yeah.
Really help tackle that black box problem with LLMs. The paper already cares about traceability, so this feels like a natural fit.
Real-world impact there could be huge for trust.
Definitely. Think transparent, auditable AI for critical applications, medicine, legal, finance, where understanding the why is non-negotiable. Probability, maybe medium for significant performance gains, but high probability for boosting explainability and interpretability.
2 really thought-provoking ideas there. Or just the usual reminder for everyone listening, these novel notions are speculative, food for thought.
Yeah, absolutely. But fun to think about.
Yeah.
So to wrap up our deep dive today, this paper really does seem like a significant step. This knowledge-aware, iterative, multi-agent approach. It looks very promising for building AI that can truly handle complex information synthesis.
Absolutely. A potential leap in capability and maybe even efficiency. If you want to get into the nitty-gritty, we've linked the full paper in the show notes for you. Thanks so much for joining us for this deep dive into some cutting-edge ML research.
And thank you for exploring it with us.
Yeah.
We'll catch you next time on The Deep Dive.